Okay, guys, we're back. This is part C of section 9.1. So don't really want to take any room on the board to write that because I may need all the room to work the problem. Okay, these last few are a doozy. A 75-pound weight hangs from a string as shown in the figure. Find the tensions T1 and T2 in the string. Round your answers to 1 decimal place. Now, here's how I kind of had to make sense of this. If I draw a horizontal line that T1, I needed to find a common point, like this would be the origin that T1, T2, and the weight all come from, okay? So if this wooden board or whatever that's above this and my black horizontal line, those are parallel. So if that's 30 degrees, then this is 30 degrees. And the same thing for T1. If that's 50, then this is 50. And so I know that much. Now on my weight is pulling straight down, okay, with a force of 75. So this is like a negative 75 J. Okay, so think of it in terms of that. Now, if I call, let's call this vector here this one, because it's going to be positive, positive. Let's call it like an AI plus BJ. Again, I'm trying to find the vertical and horizontal components of both of these. And T1, let me do it a different color. Let me do T1. I probably should have done it A and B, but let's do it CI plus DJ. Okay, I'm going to use C and D for its horizontal and vertical components of T1. Okay, so let me just write down here. T1 is going to equal CI plus DJ. T2 is going to equal AI plus DJ. And then my weight is just 0I minus 75J. Now, here's what I know about forces, okay? When we talk forces, all of your forces added together to be in balance have to equal 0. So all of these three added together have to equal 0. Okay, again, for weights and forces to be in balance, for things to pull off other things. Okay, so added together they have to equal 0. So here's what I also know on T1 and T2. So let's do T1 first here. I know that T1, the A, sorry, T1 is C. So actually, let me relabel this. Let's say this is T1. My C, because remember, for some reason, I labeled the T1 with the C's and the T2s with the A's. I apologize. But T1, my C is going to be whatever my force is. Let me go back a minute. I'm going to label, I know the force of the weight is 75J. I don't know the force of my two T's. So I'm going to call this force 2, and I'm going to call this force 1. It's like my magnitude, okay? I don't know what force 1 and force 2 are. I'm actually going to have to solve for it, okay? So I'm back to my T1 up here then. My C position, okay, is going to be force 1 times cosine 130. Now, how do I know? Why do I get cosine 130? Well, because from here all the way over to there is 130 degrees. That's where the 130 comes from. Okay. From there to there is 130 degrees. It's 180 minus 50. Okay. And I know the D part of my T1 is my force 1 times sine of 130 degrees. Okay. Now, my T2. Okay. Oh, T2 I did in red. So my T2, the tension on the second string here, is force 2. So let's on my A. So my A is force 2 times cosine 30 degrees. Okay. And my B is going to equal the force 2 times sine 30 degrees. Okay, I hope that makes sense to you guys. So force 1 is on T1, force 2 is on T2. Okay, and again, that's my magnitude. Okay, and I know that cosine gives me my horizontal, sine gives me my vertical. Okay, so I need to set up an equation. Okay, so what I'm going to do is I'm going to use the J parts here. Nope, I lied. I think I'm going to use the I parts first. Okay, so let's solve for the I parts first. So I know that AI plus CI plus 0I equals 0. Okay, that's this part. AI plus CI plus 0I has to equal 0. And then I know that all of these J parts have to also equal 0. Okay, because when you've got 3 forces working against each other, the components have to add up to 0. Okay, so this tells me then, if I do a little substitution, AI is F2 cosine 30 degrees plus C is F1 cosine 130 degrees equals 0. Okay, here's what I'm trying to do. I'm trying to solve for force 1. Okay, so if I do a little hoochie coo here, okay, force 1 times cosine 130 equals negative force 2 cosine 30. I just subtracted this term and moved it over. Okay, so that means that force 1 equals negative force 2 cosine 30 degrees over cosine 130 degrees. Okay, now I am going to have to use that and substitute it in. Okay, is everybody with me? Okay, so now let's build an equation based on my J's. So now I know, let me kind of draw a horizontal line to separate here. So in my J's, I know that, you know what I just noticed? I wrote D here and it should have been B. Whoa, what just happened? I just caught a typo. Okay, so remember all of those have to add to 0, all of these have to add to 0. Okay, so on my J's, I know that D, well, let's start with B. BJ plus DJ, okay, plus negative 75J also has to equal 0. Okay, so I hope you all see that. So I know all my I components have to equal 0, and I know all my J components have to equal 0. Okay, don't forget that this is a minus. Okay, so BJ plus DJ plus a negative 75J equals 0. So let's substitute in what the B's and the D's represent. So my B is force 2 times sine 30 degrees. Okay. I'm just going to kind of cut off the j's. Plus my d is force 1 sine 130 degrees equals, and I'm just going to go ahead and pull this 75 over. Okay. I just added the 75 to move it on the other side. Okay. All right. Now, this F1, this F1 right here. So my D, this F1, I'm going to substitute in this. Okay. So I'm going to have F2 times sine 30 degrees plus my F1 is negative F2 cosine 30 over cosine 130 times sine 130 equals 75. Okay, I literally just substituted in my F1, okay, for what I'd found in the step above. I'm using the substitution to solve a system of equations is essentially what I'm doing. Okay, got to have some more room here. So we have, and I'm going to factor out the F2 here. So if I factor out the F2, we're going to have sine 30 degrees minus cosine 30 degrees times sine 130 degrees over cosine 130 degrees equals 75. Now, when I put all of that gobbledygook into a calculator, okay, I did mine a little backwards, so let me re-enter this. Okay, so sine of 30 minus cosine of 30 times sine of 130 divided by cosine of 130. I get F2 times 1.532 roughly. Okay, equals 75. Okay, now, if I solve then for the force 2, if I take 75 divided by that, force 2 is going to give me 48.95. Okay. So 48.95. Now, what do I do with that? Well, we've got to go back and find, now that we have our force 2, we've got to go back. I can't get it all on the same screen, but I've got to find my T1 and T2. In this case, because I solved for force 2, I'm going to find my T2. Okay, so T2, let me do it in red. So T2 is going to equal 48.9. I'm going to need more room. Sorry. Let me scooch over a little farther to the left. So T2 is going to equal force 2, 48.95, times cosine, right? Cosine of what was my T2 degrees? My T2 degrees, if you look, was 30. Okay. Cosine 30 plus 48.95 sine 30 degrees. So this was my I, this was my J. if you remember correctly. So if I take that times cosine 30 degrees, (48.95) times cosine 30 degrees. I poked something in wrong. There we go. I get 42.39 I. Okay. And what did they want me to round to? Does it say? It says 1 decimal place. So actually, let me round this to 42.4 I. So this is 42.4 I plus, if I poke that in, 48.95 times sine 30, I get 24.5 J. So that is my T2, okay? So I can put that up here. 42.4 I plus 24.5 J. Now, we got to find T1. Okay, well, now that a couple different ways you can do this, but the easiest thing you can see here is if we look at our I terms, remember that C plus A has to equal 0, right? So CI plus AI plus 0I has to equal 0. So if this I is 42.4, what do you think T1's I is going to be? It's going to be the opposite. It's going to be negative 42.4. Okay, so this one right off the bat I know is negative 42.4 I. Now, how do I find the corresponding J? Again, do the math. Okay, so we've got, you can actually just look at the J parts here. So if we've got DJ plus 24.5J has to equal 75J, right? So then D is going to just equal essentially 75 minus 24.5. And of course, that's where I get my dead spots, which is going to give us 50.5. Let me scroll up so I can at least get these filled in. Okay, so up here, negative 42.4 I plus 50.5 J. Okay. Woo, that was a tough one. That was really a tough one. So lots of information here. I hope the notes are helpful. Okay. Again, just the written notes will also be saved so you can see. Okay. Let's go on to the next one, which is the same kind of deal. Hopefully we can get through it maybe a little faster. Okay, next one. This one, they were nice enough to kind of draw that horizontal line for us, right? So same kind of deal here. I'm going to let T1 equals AI plus BJ, and I'm going to let T2 equals CI plus DJ. Okay, and then my weight, this big old weight is 18,222 pounds. So the weight is just a negative 18,222J. Okay, it has no I components pulling straight down. Okay, so same kind of deal. We are going to start with the fact that, again, my AI plus BJ plus CI plus DJ plus 0I minus 18,222J all have to balance out and equal 0 because they're all kind of pulling against each other. That's what we're talking about with tension. So once again, I'm going to label this my force 1, if you will, and this my force 2 for T2. So that's my magnitude on each of the vectors for the tension, okay? So let's do the same thing we did last time. A, remember, is going to equal force 1 times cosine of 157.7 degrees. Where did that come from? Well, that came from here to here. If we take 180 minus 22.3, that's where the 157.7 comes from. Okay, 157.7. So that's my A component. My B component, of course, is force 1 times sine of 157.7 degrees. Okay, my C and D. C is going to be F2, the magnitude of my second tension vector, F2 cosine of 41.5 degrees, and D is going to be F2 times sine of 41.5 degrees. Okay, now I know I'm kind of skipping a few little steps here because we already did one just exactly like this, the last problem. So F1 times cosine 157.7 is going to equal negative F2 of cosine 41.5. Again, A plus C plus 0 equals 0. So that means A has to equal negative C. Okay, so that gives me an F1 then of negative F2 cosine 41.5 over cosine 157.7. Okay, so that's what my F1 equals. And then I'm going to use that in the next step. So the next step, I'm solving the J's. Okay, same kind of thing that I did last time. So B plus D plus a negative 18,222 has to equal 0. Or B plus D has to equal a positive 18,222. That's what I'm going to do. And now my B, well, let me go ahead and write it. So I've got F1 sine of 157.7 plus F2 sine of 41.5 has to equal 18,222. Well, now this is where I take my F1 and substitute it into here for F1. Okay, so now I've got negative F2 cosine 41.5 over cosine 157.7 times sine 157.7 plus F2 sine 41.5 equals 18,222. So now factor out the F2. Okay, and actually I already did this step, so I am going to say that this boils down to F2 times 0.96979 equals 18,222. So I factored an F2 out of both of those terms and then did the math to figure out what was left was that 0.96979. Okay. Just like I did on the last one, factor out the F2. So that tells me then that F2 equals 18789.65. Wow. 18789, 18,789 and 65 hundredths. Now, what does that do to help us? Well, once again, we have to go back up to what my A, B, C, and D equal. Okay, so let's see if I've got enough room over here. So my A, okay, my A, oh, actually I solved for F2, so I need to start with my C and my D. So C is F2 times cosine 41.5. So if I plug in the F2 I just found, poke that in the calculator, what do I get for C? And this, you're supposed to round to the nearest whole number. So for my C, I get 14073. And of course, that's going to end up with an I. Okay, my D is F2 times sine of 41.5. Well, sine of 41.5 times that F2, 18789.65, is going to give me 12450. And that, of course, is J, 12450. So that's what actually goes up here, is 14073I plus 12450J. Okay, so this is my T2. It's a little easier to see down here. Okay, now, how do I get T1? Well, again, T1, your A has to equal your negative C, right? So that just means that A equals negative 14073. Gotta love the dead spots. 14073. So that's your A. Okay. And then if you remember, okay, your B plus D, let me write it over here. Your B plus D had to equal the 18,222. So that means your D equals, or sorry, your B equals 18,222 minus D. So that is going to give me 5772. And that's J. So this right here is your T1. So back up here in your blocks for your answers, it would be negative 14073I plus 5772J. Okay, hope that made sense. Lots of calculations, I know that. Okay, this one kind of sucked, no way around it. Okay. So again, these are the two kind of basic formulas. B plus D equals 18,222 and A plus C equals 0. Okay, so that gives me T1, T2. Woo! That was a hard one, kind of like the previous ones. The next couple aren't so bad. Let's move on. We got to finish this section. This is a really long section. Find the horizontal and vertical components of the vector with the given length and direction, and write the vector in terms of the vectors I and j. Round your coefficients to 3 decimal places. Whew. Okay, this one, pretty easy. Compared to the last couple we did, very easy. So we have a vector with magnitude 5. Okay, actually, let me do it in a different color. Magnitude 5, and my theta is just 10 degrees. So I am trying to find the horizontal and the vertical components. So that's my J, that's my I. Okay, so you can do it a couple different ways again, but remember, it's really just using sine and cosine. Okay, so if you remember, your I is 5, going to be times cosine 10 degrees. Your J is going to be 5 times sine 10 degrees. Okay, So you poke that in your handy dandy calculator, and your I gets you 4.924. Your J gets you 0.868. So your answer would just be 4.924I plus 0.868J. That's your vector. Okay, set to 3 decimal places. Okay, that one was easy. Next one. Magnitude and direction and degrees of the vector. Again, we've already done some like this, but remember, magnitude is like using Pythagorean's theorem, right? So magnitude of V is the square root of 8 squared plus 6 squared, which gives me 100. 64 plus 36 is 100. Sorry, doesn't give me 100, it gives me 10. Square root of 100 is 10. So my magnitude is 10, okay? And again, now I have to find direction. So if I'm going to the right 8 and up 6, it's going to be somewhere like up in here, right? That's my vector. So this was 6 and this was 8, right? So I'm trying to find theta. That's my theta. So I just do tan theta equals opposite over adjacent. So arctan of 6/8 or 3/4, okay, is 36.87 degrees. So 2 decimal places. And don't forget, they already have the degrees there, so you don't have to add it. Okay, next one. Hallelujah, praise the Lord. We have 2 left. Now, this one, we're talking about jets again and flying and degrees and all that good jazz. A jet is flying through a wind that is blowing with a speed of 60 miles per hour in the direction of north 30 degrees east. So every one of these, if I come in here and would make a XY chart here, this is our wind, the blue arrows are our wind. This right here is your 30 degrees, okay? So that makes the wind relative to the positive x-axis, that makes it 60 degrees, okay, down to the positive x-axis. Okay, just wanted to point that out. And then the jet has a speed of 770 miles per hour. So remember, that's its magnitude. Okay, 770, that's its magnitude relative to the air. And the pilot heads the jet in the direction of north 30 degrees west. So north 30 degrees west. Again, if I draw my XY coordinate, if it's 30 degrees to the left of north, that makes this whole thing 120 degrees, right? So 120 degrees, 90 plus 30. Okay, so find the true speed of the jet. Okay, well, first I got to find my I and J components. Okay, so the wind, let's do this in 2 different pieces here. The wind I and J is going to be 60 times cosine, because 60 is the magnitude, okay, remember. 60 times cosine of 60 degrees I plus 60 times sine 60 degrees J. That's my wind. Now, my jet is going to be 770 cosine 120 degrees I plus 770 sine 120 degrees J. Okay, so 770 times cosine 120 for the I and 770 times sine 120 for the J. So if I poke that in a handy dandy calculator, I get 30I plus 30 root 3 J. That's the wind. The jet, I get negative 385I plus 666.84 J. Okay, so wind, jet, that's their horizontal vertical positions. That's the IJ for their vectors. Now, in order to find the true speed, well, first of all, I've got to find, let me back up, I've got to find the true speed of the jet. Okay, so before I find the true speed of the jet, I have to find the velocity of the jet. Okay, so velocity of the jet with the wind working on it. Okay, velocity of the jet with the wind, I have to add them together. I have to add the wind plus the jet. I have to add them together. Okay, so that is going to give me negative 355I plus 718.8 J. Okay, so I've got the true wind, the true jet, and then I've got the velocity of the jet with the wind. Okay, and again, this, let me just put underneath it, this was 30 plus negative 385, and this was 30 root 3 plus 666.84. That's where those two came from. I literally am adding the I components together, adding the J components together of the wind and the jet. So now true speed. True speed is the same thing as magnitude. True speed is the same thing as magnitude. So in order to find the magnitude, I have got to take the square root of negative 355 squared plus 718.8 squared. And what do I get? I get approximately 801.685, yada, yada, yada. But it says round to the nearest integer. So my final answer here is 802. Okay, so the true speed, which is the same thing as magnitude, is 802 miles per hour. Okay, so the wind, again, is actually helping speed up the plane a little bit. Now, find the direction of the jet. Okay, find the direction of the jet. So I've got to kind of go back to my velocity of the jet with the wind. So if I draw my little XY coordinate again, that you all know I love to draw, negative 355. Okay, that was my horizontal change. And way up here somewhere would be my 718.8. Okay, so here's my jet. Okay, its magnitude is 802. Okay, so that's like the hypotenuse here. And I'm trying to find theta, but what I'm going to have to find in the meantime is this right here. Okay, I'm going to have to find that. So tangent theta equals 718.8 over 355. Whether you do positive or negative, it doesn't really matter. You are going to get that theta equals 63.7. Now, that theta is 63.7 degrees. What they want, though, is north so many degrees west. So what they actually want is not theta. They want, I don't know, let me call it delta. They want delta. You can't hardly tell my little delta symbol there. It's a lowercase delta in Greek alphabet. So that's what they want. So how do I get that? It's 90 minus 63.7, which is going to give me 26.3 degrees. So it is north 26.3 23.3 degrees west. Because again, you would head north first and then turn west the 23.3 degrees if theta is 63.7. Okay, one more. I know this ended up being the longest one, but one more and then we're done. A jet is flying through a wind that is blowing with a speed of 45 miles per hour in the direction of north 30 degrees east. The jet has a speed of 760 miles per hour relative to the air. Same kind of deal we just did. Okay, so we have, let me draw a picture here. So the wind is, I think they use blue for wind, I'll do that the same. So the wind is north 30 degrees east. Okay, so this is 30 degrees. So this is wind. Okay, and the jet has a speed of 760 relative to the air. In what direction should the pilot head the plane for the true course to be due north? So you know your jet is going to have to be headed somewhere over here so that the wind then pushing against it, right? Your wind pushing against it is going to push it due north. So you want to end up going this way. Okay, so now due north, remember, is like 0I plus whatever J. We don't really know what that is. Okay, our wind, remember, is 45 is its magnitude. Okay, so for the wind, let's figure out the I component. So the I component for the wind, if that's 30, this is going to be 60, right? So the I component for the wind is going to be 45 times cosine 60 degrees. That gives me my I. Okay, again, I component for the wind. For the jet I don't know much about. I just know that its speed is 760. Okay, so for the jet, the I component is going to be 760 times cosine theta. I don't know what theta is yet. Okay, this whole thing here would be my theta. Not sure what that's going to be yet. I'm going to have to solve for it, times I. And then those two added together, okay, these two added together have to equal 0 because that is my I component of where we should end up. Okay, actually, let me write that in purple. So that should equal 0I. Okay, so the I component of the wind plus the I component of the jet should equal 0I. So that's going to be my equation that I have to solve. So 45 times cosine 60 degrees plus 760 times cosine theta equals 0. That's what I'm solving for. So this, if I, subtract this off, so 760 cosine theta equals negative 45 cosine 60 degrees, and then divide off the 760 cosine theta. When I poked that in my calculator, I end up with negative 9/304. Okay, so you're going to have to divide off the 760 from both sides, and then that reduces to negative 9/304. So then that tells me that my theta, if I poke that in a calculator, my theta is 91.6965. Now, that is just past, obviously my picture doesn't quite do that justice. So that means my jet is literally just past the 90-degree mark. Okay, so they want the answer in north so many degrees west. So what they want is they want this little bitty piece right here. They want that theta. Okay, north so many degrees west. So we are going to take well, actually, I was going to do it backwards there. So we're going to take the 91.6965 minus 90 degrees. And that's going to give us, I think they just want one decimal place. So 1.7. So that would be my answer. 1.7 degrees. Okay. So the whole theta was 91 point whatever. I shouldn't really call this theta. I should call this x or something. So then x is going to equal 91 point whatever minus 90. Okay. All right. Whew, that concludes section 9.1. This was a doozy, I know. 9.1 is done. We only have one section left.